6.1 Functions. Learning Intention. To understand functions using mapping diagrams and identify the domain, range, and codomain. Success criteria. I can substitute values into a function rule correctly. I can complete a table of values for a given function. I can write ordered pairs, couples generated by a function. I can draw and interpret a mapping diagram. I can identify the domain from a mapping diagram. I can identify the range from a mapping diagram. I can identify the codomain and explain the difference between range and codomain. Functions. A function operates on a set of input numbers to produce a set of output numbers. Y equals 3x plus 5 is an example of a function, where a given set of values of x is called the input set, and the resulting set of values of y is called the output set. F of x equals 3x plus 5, or f of x maps to 3x plus 5, are two other ways of expressing the same function. So basically what's highlighted in yellow, they all mean the exact same thing. So we can say y equals, or f of x equals, or f of x maps to. That little arrow there, we say maps to. If x is an element of 1, 2, 3, 4, 5, so if x is 1, 2, 3, 4, or 5, then f of x equals y, which equals 8, 11, 14, 17, and 20. So where did these numbers come from? So if we were to sub 1 into the function in place of the x, so for example here we had f of x equals 3x plus 5, so replacing that x with a set of brackets and putting 1 into the brackets, we get 3 times 1, which is 3, plus 5, which is 8. So that's where that 8 came from. Likewise, if we sub in 2 in place of the x, so replacing the x with brackets and putting 2 into the brackets, we get 3 times 2, which is 6, plus 5, which is 11. So that's where that 11 came from. Likewise, if we sub in 3, 3 times 3 is 9, plus 5 is 14. That's where the 14 came from. If we sub in 4, 3 times 4 is 12, plus 5 is 17. That's where the 17 came from. And 3 times 5 is 15, plus 5 is 20. That's where the 20 came from. So our x values, our inputs, were 1, 2, 3, 4, and 5, and our y values, our outputs, were 8, 11, 14, 17, 20. A function may be written as a set of ordered pairs or couples. So the x comes first inside a set of brackets, the input comes first, then a comma, and then the output comes second. So the y value comes second. So for example, 1, 8, 2, 11, 3, 14, 4, 17, and 5, 20. So I've highlighted in blue all the x values. They were our inputs. So I'm labeling each of those blue numbers as x. They were our inputs. And I've highlighted here in green our outputs. And I'm going to label each of those as y. Examples of inputs and corresponding outputs are common in everyday life. A calculator is an example of a function machine. If you input 6 and press x squared key, the output is 36 because 6 squared is 36. If the barcode on the cover of your book is scanned, the price of the book will appear on the screen of the scanner. When a farmer applies fertilizer, that's his input, to his crops, the yield, the output will be increased. So rule, domain, and range. Central to every function is the rule. So for example, the output value is equal to 5 times the input value plus 4. Now this is just one example of a rule. The output value we can call y, and the input value we can call x. The domain, which is a given set of input values. For example, x is an element of 1, 2, 3, 4, 5. So this is one example telling us that the input, the x values, are 1, 2, 3, 4, and 5. Or another way we could say it is x is greater or equal to minus 2, but less than or equal to 4, where x is an element of z. So z being an integer, so a positive or negative whole number. So this would tell us that the inputs into whatever function we're using are minus 2, minus 1, 0, 1, 2, 3, and 4. So it goes from minus 2 up to 4, including all the integers in between. The range, which is a set of output values, which we're going to label as y. So input we label as x, output we label as y, resulting from the rule operating on the domain. So to summarize, we've got our input and then our output. So the input is x, the output is y. And the new words for that now are domain and range. So the input is the x values, or could be just one value. And this is known as the domain. And the output is the y value or values, and that's known as the range. Mapping diagram. The domain, input values, and range, output values, can be represented by a special type of diagram called a mapping diagram. Each input number is mapped onto its output number. So here we have our inputs, and here we have our outputs. So these are our x values, and these are our y values. So our inputs are known as our domain, and our outputs are known as our range. In the mapping diagram above, notice that there is one and only one output number for each input number. So 1 maps to 1, 2 maps to 6, 3 maps to 11, 4 maps to 16, 5 maps to 21, and 6 maps to 26. So in mathematics, we use the word function for any rule that produces one output value only for each input value. So our domain, also known as x or x values, are our input values, and our range, also known as y, is our output values. And this is known as a mapping diagram. So each input, x, is mapped onto its output, y. So our domain are our x values, and our range is our y values. So our input numbers, our x values, are the domain, and our output numbers, our range, are our y values. Now, what's highlighted here in yellow is the most important part. In the mapping diagram above, notice that there is one and only one output number for each input number. So in mathematics, we use the word function for any rule that produces one output value only for each input value. So let's have a look at a function, a mapping diagram that has a function, and then another mapping diagram that is not a function. So identifying functions. When a function is represented by a mapping diagram, each element of the domain maps to one and only one element of the range. So this is the most important part, one and only one. So our domain are our x values or our inputs, and the range is our outputs or our y values. So consider these two mapping diagrams. So we have a domain and a range, and on the next one we also have a domain and a range. Now in the first one we've got letters, in the second one we've got numbers, but that doesn't matter, that doesn't make any difference. So we label our domain as x and our range as y, and our domain as x and our range as y. And we also label domain as input and range as output, and domain as input and range as output. So lots of similarities so far. Diagram 1 is not a function. So this diagram here is not a function. Now it's not because of the letters. That doesn't matter. It can be letters or numbers. But it's not a function since the element b, so there's b, is paired with two different elements in the range. So we've got b comma e, so b maps to e, and b comma f, b maps to f. So this is not a function. So b maps to e, and b also maps to f. So that cannot happen in a function. We cannot have two arrows leaving the same element. We cannot have two arrows leaving the same element. Okay, I'm going to two different outputs. Diagram 2 is a function. Okay, so diagram 2 is a function, since each element in the domain is mapped onto one and only one element in the range. So what is the rule of this function? So let's have a look. So 1 maps to 1, 2 maps to 4, and minus 2 also maps to 4. So this function is y is equal to x squared. So the rule for this function is x squared. So 1 squared is 1, 2 squared is 4, and minus 2 squared is 4. So we can have two arrows going to a y value. It is possible to have two arrows going to a single y value. That's okay for a function, but it can't be the other way around. We cannot have two arrows leaving an x value. That does not make sense for it to be a function. So on the right-hand side, we have a function. On the left-hand side, we don't have a function. We just have a relation. Note, when a function is written as a set of couples, no two distinct couples will have the same input. So remember, no two distinct couples of a function can have the same input value. So 1, 4, 2, 5, 3, 6, 4, 7 is a function, as no two couples have the same input. No two couples have the same x value. 2, 7, 3, 8, 3, 9, 4, 12 is not a function, as the input 3 has two different outputs. So we can see 3 is the first number in each of the couples, so 3 is the x value. And 3 maps to 8, and then 3 maps to 9. So this will not work as a function. So if we go back to our first set of couples, 1, 4, 2, 5, 3, 6, and 4, 7. So I'm just taking the first number from each of the couples. So we've got 1, 2, 3, and 4. So these are our x values. This is known as our domain or our inputs. And then I have our y values. So 4, 5, 6, and 7 are our y values, or our range, or our outputs. So 1 maps to 4. So I'm going to put an arrow joining 1 to 4. And then 2 maps to 5. So 2 maps to 5, and then 3 maps to 6, 3 maps to 6, and then 4 maps to 7, 4 maps to 7. Our second set of couples, so we've got 2, 7, 3, 8, 3, 9, 4, 12. So we've got our x values, which is our domain or our input. So we've got 2, 3, and 4. So we don't need to write the 3 twice. So we're just going to have 2, 3, and 4. And our y values, our range or our outputs, is 7, 8, 9, and 12. So 7, 8, 9, and 12. So 2 maps to 7. So join 2 and 7 with an arrow. And then 3 maps to 8. So 3 maps to 8. And then 3 also maps to 9. So 3 maps to 9. And then 4 maps to 12. So 4 maps to 12. So we can see that this is not a function because the 3, which is the x value, has 2 arrows leaving it. And this cannot happen in a function. So this mapping diagram is not a function because 3 has 2 arrows leaving it. Whereas this first mapping diagram is a function because each of the x values, 1, 2, 3, and 4, has only 1 arrow leaving it. Notation for a function. Consider this rule for a function. Double the number and add 4. If we input x, the output will be 2x plus 4. So double the number and add 4 can be rewritten as 2x plus 4. The rule for this function may be written in any one of these 3 ways. So we can have f of x equals 2x plus 4, or f of x maps to 2x plus 4, or y is equal to 2x plus 4. So they all mean the same thing. And if we wanted to input our x value as 3, we would do the same thing for each of them. So we would have f of 3 is equal to 2 times 3 plus 4, which is 10. Or f of 3 maps to 2 times 3 plus 4 is equal to 10. Or y is equal to 2 times 3 plus 4 is equal to 10. So it's just 3 different ways of writing it. It's just different notation, but they all mean the same thing. So they all mean the same thing. We've inputted the same x value, so we get the same y value out. The codomain. Take these two sets. A is equal to 1, 2, 3, and B is equal to 1, 3, 5, 7, 9, 11. If we are asked to list the couples of the function f of x maps to 2x minus 1, where the input numbers come from set A and the output numbers come from set B, we could set up a mapping diagram as follows. So I've highlighted in yellow my inputs and I've highlighted in blue my outputs. So just to show you, if we were to sub into this function, so the function is 2x minus 1. So that's here. So fx maps to 2x minus 1. So if our inputs, our x values are 1, 2, and 3, we swap the x for brackets, and we put 1 into the brackets, then 2, and then 3. So 2 times 1 minus 1 is 1, 2 times 2 minus 1 is 3, and 2 times 3 minus 1 is 5. So inputting 1, we get an output of 1. Inputting 2, we get an output of 3. Inputting 3, we get an output of 5. So the couples are 1, 1, 2, 3, and 3, 5. So 1, 1, 2, 3, 3, 5. 1, 1, 2, 3, 3, 5. So the set A is the domain, so our x values 1, 2, and 3. So I've highlighted them there in yellow. The range is 1, 3, and 5. So we can see 1 maps to 1, 2 maps to 3, and 3 maps to 5. So the range is 1, 3, and 5. So highlighted there in green. Now notice that we have 7, 9, and 11 that don't have any arrows going to it. So the set B is called a codomain. That is the set of allowable outputs or possible outputs. So the codomain is 1, 3, 5, 7, 9, and 11. So all of these numbers inside of set B are known as the codomain. But the 3 in green, the 3 that have arrows going to it, they are known as the range. So our x values, our inputs, are our domain. So the set of inputs is called a domain. The set of outputs is called a range. So 1, 3, and 5 are the range. And the set of possible outputs is called a codomain. So that's highlighted in blue. So that's all of the elements inside of set B, even the ones that do not have arrows going towards it. Example 1. A function is defined as f of x maps to 3x minus 2. The domain of f is 0, 1, 2, 3, 4. Represent f on a mapping diagram and write out the couples generated. What is the range of f? So our domain, our inputs are our x values, and our function is f of x maps to 3x minus 2. Or we could say y is equal to 3x minus 2. Or we could say f of x is equal to 3x minus 2. They all mean the same thing. So we're going to draw a mapping diagram. So in our mapping diagram, we have our domain. So our inputs are 0, 1, 2, 3, 4. And then we have our range, our outputs. So I'm going to do some rough work. So our function is f of x maps to 3x minus 2. So I swap the x for brackets, and I'm going to first of all input 0. So 0 is our first element in our domain. And 3 times 0 minus 2 is minus 2. So we're going to have minus 2 is our first element in the range, and 0 maps to minus 2. So we write out our function again and swap the x for brackets, and now into the brackets, our next element of our domain is 1. So 3 times 1 minus 2 is 1. So 1 goes into the range, and 1 maps to 1. Now I know our elements in our domain are 0, 1, 2, 3, and 4, but they could have been anything. They don't have to go in order necessarily. So it could have been 2, 4, 6, and 8, for example, or it could be any numbers whatsoever. In this case, it's 0 up to 4. We write out our function again, swapping our letter for brackets, and now we input 2. And 2 times 3, or 3 times 2 minus 2 is 4, so 4 goes into our range, and we map 2 to 4. So we write out our function again, swapping our x for brackets, we input 3 into the brackets. 3 times 3 is 9, minus 2 is 7, so 7 is drawn into the range, and then we map 3 to 7. And finally, we write out our function again, swapping the x for brackets. We're inputting 4 this time. So 3 times 4 is 12, minus 2 is 10. So 10 goes into the range, and 4 maps to 10. So we don't have any elements left over, so the range and the codomain are the same. Now we want to write out the couples that are generated. So our couples generated, 0 maps to minus 2, so we've got bracket 0, comma, minus 2. Then 1 maps to 1, So we've got 1, 1. Then 2 maps to 4. We've got 2, 4. Then 3 maps to 7. So 3, 7. And 4 maps to 10. So 4, 10. It's very important that the domain comes first and the range comes second. Wrong to say 10, 4. It has to be 4, 10. That's really important. So the domain, our x values or our inputs, must always come first, and the range, our y values or our outputs, must always come second. Now we want to write down what's the range of f. So the range of f, so we've got our squiggly bracket, and then we just list off our range. So -2, 1, 4, 7, 10, with commas in between and a squiggly bracket. Example 2, complete the table. So we have our input, our x values, -2, -1, 0, 1. The rule or the function is 3 minus 2x. The output will be y, and then we put our couples together. So we're going to write out our function or our rule, replacing the x with a set of brackets. And we do that for each row. We're going to then put -2 into the first bracket. And 3 minus 2 multiplied by -2 is 7. So our couple is going to be -2, 7. So -2 is our input and 7 is our output. Then we put -1 into the brackets, and 3 minus 2 times -1 is 5. So our couple is -1, 5. Then we input 0. So we have 3 minus 2 times 0, which is 3. So our couple is 0, 3. And then we have 3 minus 2 and we input 1. So 3 minus 2 times 1 is 1. So 1, 1 is our couple. Example 3. Write down the domain, range, and codomain for this mapping diagram. So we have -2 maps to -4, 2 maps to -4, 3 maps to 6, and 7 maps to 9. And then we have 2 with no arrow going towards it, -3 with no arrow going towards it, and 4 with no arrow going towards it. So this is our domain, and this is our codomain. So the domain, our inputs, our x values, are -2, 2, 3, and 7 with brackets, squiggly brackets and commas in between. Our range are our outputs, our y values. So they are only the elements that have arrows going towards them. So -4, 6, and 9. -4, 6, and 9. And then our codomain are all our possible outputs. So the ones with arrows and the ones without. So -4, 2, 6, -3, 4, and 9.